Hello, so continuing on weekly contest 332, the third problem is substring XOR queries. So what this problem tells us is that we get a binary string S, and we have a 2D integer array of queries that has two numbers, first and second. And what we want to do is for each query, we want to find the shortest substring of S of the string such that the decimal value that we get from the string. So by decimal value, they mean, let's say if we take the substring 101, so this would be the binary representation. So the decimal value of this is 5, because 2 to the power of 0, which is 1, plus 2 to the power of 2, which is 4. So that gives us 5. And so the problem says we want to find the shortest substring S, where the decimal value of that substring, if you take that, XOR it with the first of the query, the first element of the query, that gives you the second element of the query. It's a little bit convoluted, but essentially the substring, the value, XOR the first element of the query equal to the second element of the query. That's pretty much it. And so what we want is for each query, we want to return for the endpoints of this shortest substring, if there is one. If we can't find it, we just want to return -1 and -1. If we have multiple answers that have, let's say, the same short length, then we want to return the one with the smallest left boundary, right? And then we want to return for each query, we want to return the list of the answers for each query, right? And that's pretty much it. So if we take a look at the first example here, we have the first query 05. The shortest string that will give us this condition here is taking 101, for example. That will give us value of 5. And if we use that, 5 XOR 0 is equal to 5. So that's valid. For the second one, 1 and 2, if we take the substring 0, 2, 3, so 2, 3, so just 1, 1, that has the value of 3. And 3 XOR 1 is equal to 2. So we just take this substring, and the boundaries of this substring are 2 and 3. So that's what we have here. And then for the first one, the boundaries were 0 to 2, and so that's what we have here. So that's roughly the idea. Now, looking at the constraint here, you can see that the string length can be 10 to the power of 4, the number of queries 10 to the power of 5, right? And the first and seconds are 10 to the power of 9. So already this tells you that we can't do something that is O of the length of the string by the length of queries. We can't do that. So we'll have to do some pre-processing. So let's see how we can solve it. Okay, so how do we solve this? So the first observation to make is that this property of XOR, so let's say we have this X XOR first equal to second. That's the property that we are given. So X here is just the value that we get. So if you have A XOR B equal to C, then what you can do is just apply XOR to both sides, right? So if you do that, then let's say we apply XOR of B, right? Then B XOR A XOR B is equal to C XOR B, right? But B XOR B, right, is known to cancel each other out. And so if we cancel this here, then we get A is equal to C XOR B, okay? So that's exactly what we can apply here, except we can apply it on first. So what this would mean basically is that X XOR first, we know that it's equal to second, so we can just XOR both sides with first. So that will get us first XOR X XOR first is equal to second XOR first. So what this will mean basically is that this cancels out, and we get X is equal to S XOR F, right? And that's exactly what we get here. X is equal to first XOR second. Okay, that's what we had from this. Okay, so once we do that, so we have that property, so we know since both these values are known, what we are actually looking for is just the substring that has this value. So it's a lot easier to do now. The second observation is that both first and seconds are integers, right? And integers can fit in 32 bits. right? And so we know that at least the max, since x is equal to these two, since both can fit in 32 bits, that means that the XOR value can also fit in 32 bits. That tells us immediately that x can fit in 32 bits, right? Okay, so we know that even if we want to try all substrings, we don't need to try substrings with length bigger than 32, right? Because x can be only 32. Because s is just the binary values, right? And we want a substring of s. We want x to be a substring of s, right? But since x can fit in 32 bits, we know that we only need to try substrings that have size less than or equal to 32. Expanding on that even more, the constraint tells us that first is smaller than or equal to 10 to the power of 9, and same thing for seconds. Well, 10 to the power of 9, if you just type it in Python or in any command line, it's actually smaller than 2 to the power of 30 minus 1, right? So this already tells us that it's not just 32, it's actually smaller, because 10 to the power of 9 is smaller than this value. This value can fit in 30 bits. That means that 10 to the power of 9 can also fit in 30 bits. So that means here actually, because both values can fit in 30 bits, that means that their XOR also fits in 30 bits. So here actually we only need 30 bits, which means here we need only substrings of length between 1 and 30 bits, right? Why is this even important? Because the problem applies to finding a substring that has the first XOR that is equal to first XOR second, right? We know that there is a brute force solution, which is try all substrings, right? So we can just go for I in all the range of the length of S, right? And then we can have J just be also from I plus 1 to N, right? The length of S. And we can try all substrings, right? But this is O of N squared. And N is 10 to the power of 4. So this is one pass, right? But because we know that the substring of x can be at most of length 30, instead of doing this, we can just go for I in the range of N. And for J just needs to be in the range of I plus 1 up to I plus 30. And in Python, we need to just say 31 so that we can reach 30. Because the length is at most 30, for I, we only need to try up to 30, I plus 30, because the length can't exceed 30, right? And so because of this, our time complexity goes down from O of N squared, it goes down to just O of 30N, right? Because this is just O of 30. So it's sort of only O of N because the constant just cancels out, right? Okay, so that's the important piece. And so we know that we only need to check these two. Now, what is the pre-processing step that we need to do? Well, the problem says that so when we do for each string, we want to get the smallest substring, the shortest substring, right, that has this property, right? So what we can do basically is just have a hash map, right? So we can just have a hash map here that stores the substring values in the range that those substrings have, right? So we can just have our substring here is going to be I to J plus 1, right? And then we can just convert this one to a decimal value, right? So just get the decimal for this string. And then we add it to our map. Let's call our map of values. What do we need to add? We need to give a range, and the range here of the substring is just from I to J, right? And in Python, for it to be inclusive, you just do I plus J. IJ here, so this is the range that we have. Now there is one other property, because the problem says we want the shortest substring. So we need to be careful here when assigning the range, right? because we want to check if it's already in the values. We want to make sure if the new range is smaller, we want to override, but if the new range is bigger, we don't want to override, because that won't be a shorter substring, that would be a bigger substring. So that's the property that we need to maintain here, which is basically if this substring is not yet added to value, so this is the first time we encounter it, we want to set it anyway, right? So in this case, we do want to set this range. Why also we want to set it? Because the problem says if you have two strings of the same length, we want to take the one with the smallest left. And since this one is going, I is going in from left to right, this would be the smallest left, right? So this means here that here, if they are equal, we don't override because this one is better. The only case we want to override is if the length, the new length, is shorter than the previous length, right? So here, only if how do we compute this? Only if the existing values of sub, right, for the range, so the first position, to get the size of the range, we just do 1 minus the values in sub at 0. So this will give us a range for the, okay, let's just make this a little bit more space. So here we just need the size of the previous one to be bigger than the new one. The size of the new one is j minus I. So only in this case is that we want to override the range, because we found a shorter substring, right? But if they are equal, we leave the first one because it has the smaller I, right? So that's the idea. Now, once we have these values here, the next step would be to just go through the queries and just get the value x, right? And just get the range from the values map. So the rest is actually pretty easy. We don't need to do anything. So let's just apply it to an example and just see what it looks like. So if we have 1 0 1 1 0 1, right? So this would be our S, and our queries are 0 5 1 2, and let me just add the indices here. So this would be something like this, and the indices are 0 1 2 3 4 5. Okay, so here what do we need to do? We need to have our values map. So our values map is going to be just a substring like this. And so for each I, so first our I is here, and so for each I we'll go for j's from I plus 1 up until 32. Here it's smaller than 32, so sorry, it's smaller than 30, so we can go up to the end. So the first string we have, substring, is going to be 1 0, right? And so for this, sorry, here actually we need to go up to I only, because we want to consider the substring of length only one binary, right? And so here with value just 1, we want to check if it's already in the values. It's not, so we say 1, and the range is 0 to 0. And then we increment j, right? So we go 1 0, so j becomes there. And now it's the substring value is, so 2 to the power of 0 was 1, and here 2 to the power of 0 multiplied by 0, and then 2 to the power of 1. So this is 2. So the decimal 2 is for the range 0 to 1. And now we move j here, and so 1 0 1, and 1 0 1 is just 2 to the power of 0 plus 2 to the power of 2, which is 1 plus 4, which is 5. So we have 5. The range is 0 to, the range, sorry, is 0 up to 1 0 1 2. Okay, and then we keep going. Let's suppose we kept going until the end. I won't do that manually here, but just to show you, once j reach the end here, what happens is we go to the next I. And so now we move our I to this position here, right? And then we check the substring, and so we move j here. So the next substring is 0. So we have definitely 0 that is in the range 1 1 1, right? Because 0 is not in the array yet. and then we move j here, so we have 0, 1. This is 2 to the power of 0, which is equal to 1. But we already have that, right? It's the same length, so we keep this one, right? And so we move j again. Now we have 0, 1, 1. So it's 2 to the power of 0 plus 2 to the power of 1. That gives us 3, right? So that gives us 3. So 3 here is in the range 1 to 3, right? And then we keep going, and then we will find that we have also 2, 3 here for the range, so for the value 3. So, and then for 2, 3, so once we move I here to 2, right, and j here, we'll get 1, 1, which is also 3, right? And so if we compare this one, which is the range 2 to 3, the length here is just 1, but the length here is 2. So this here will say that this one is better, and so we need to override it, so we replace it here. And so here we have 2, 3. Okay, and so now we are done. Now we just go through our queries, and so we go through for first and second in queries, right? And x is going to be equal to first, second, and then we just grab whatever is in the value. So for the first one, 0 to 5, right? 0 XOR 5 is just 5, so we go to 5, and so we have the answer is 0, 2 here for our answer array, right? And then for the second one, 1 to 2, well, 1 XOR 2 is just 3, right? So 1 XOR 2 is equal to 3, so we go here and we grab 2, 3, and that's the right answer. Now, if we don't find it, the problem says to just add -1, -1, so we will also handle that. And the second piece is going to be just O of Q. So overall time is going to be, for the first one, we are just doing 2 loops that are O of 30n, so it's O of n. For the second one, we are doing O of Q, the length of queries, so overall is just O of n plus Q. And in terms of space complexity, we are using this values map, right, which is going to have at most the number of possible substrings, right? And that's 30n, so it's O of n space as well. Yeah, so that's pretty much the idea here. Now let's implement it and make sure it passes test cases. Okay, so let's implement the solution we just saw in the overview. So first we just need the map that we want to insert values in, and we need the length of the string. And then we need to do 2 loops. So with the first one just for I. The second one for j, we want to go from I, of course, because we want to get a string of length 1. But we want to go up to 31, right? It is just to go up to size 30. 31 just because Python range needs an additional value to go to that number. But here, in case the length of the string is smaller, we want to just do min so that we don't exceed the length of the string. So it's going to be min n plus 1 because we want to go up to n. And then that's just the boundary that we have there. Now to get the substring, it's just going to be from I to j. In Python, to get it correctly, we want to do I to j plus 1. And we want to convert this one to a decimal, right, from the... this is a binary representation. It's going to be a series of 0 and 1. So to convert it in Python, we can just use int with base 2 to tell it to convert it from binary to an integer. And now if it's not in the values yet, then in this case, we just add it without saying anything because it doesn't exist. So this one is the best one we have. But if it exists, we want to replace only if the new one is shorter. And the new one is shorter from the previous one if the length of the previous one, which is just the values of 1, which is j, minus at 0, which is I, is bigger than the new one, than the length of the new one. So if the previous one is bigger, that means the new one is shorter, right? So that means this new length is shorter. In that case, we want to replace. But otherwise, we don't want to replace. And then we just have our result, and we go through first and second in queries. And we know that our x value is just first XOR second from the formula that we saw. And now if it's in values, if x is in values, right, then we can just add res.append the range that we get from, that we got from here, right? So this is actually a list, sorry. But if it's not there, the problem says to just add -1, -1. Pretty simple like this. And we want to return res, right? The result list. And so if we run this, it should work. Let's submit. And that passes our test cases. Okay, so pretty straightforward. The main idea here is that if you get something where O and squared don't pass with a substring, think about, can we do still substring but limit the size of the second loop? And this often works either with binaries or with alphabet letters, because if they are all lowercase, then you just need to iterate for the possible lowercase letters, which are just 26. Or even you can add uppercase letters, and that still would be constant number. So that's the main idea here. The second idea is this XOR operation, the fact that you can kind of arrange it to have x equal to first XOR second. Yeah, so that's pretty much it for this problem. Please like and subscribe, and see you on the next one. Bye.